Hello, hello. My name is Sylvester Sibi. I am working as a design engineer in Axelmo Dynamics. Okay, so here we are here to learn on Arduino. Okay, so let's check what is Arduino first. Okay, so this here, just wait a second. This is how Arduino looks. Okay, I think you may be familiar with this or you may not, but Arduino is a simple way to enter into the world of programming. Okay, so as a beginner, it is best to start with an Arduino. Okay, so let's check when was Arduino. Okay, Arduino was started in 2005 as a tool for students to learn programming. Okay, so I think okay, the company was started in Italy. Okay, we don't want that kind of stuff. Okay, so this is and Arduino is low cost and it's easy way for beginners to enter into the programming world. Okay, so we can easily connect it with sensors like widely available ultrasonic sensors, IR sensor. Okay, but you won't get this because this is custom made from our company. Okay, so such sensors are like battery monitors like this. Okay, sorry, not battery monitor, just a monitor. It's like this. Okay, so what then? What was the purpose? Okay, they also uh, okay. So you can see original here. So I think it is better to use a PDF. Okay, so let's go for a PDF. Okay, so you can see here Arduino is an open platform used for building electronic projects. Okay, um, uh, okay, so the software used to okay, so the software used to run programming in Arduino is called IDE. Okay, Integrated Development Environment. Okay, so let's go to the main components of Arduino. Okay, I think you can see now. So you can see a USB plug right here, digital input output pins, serial output pins, Atmega 116U to USB controller, then power LED indicator, in circuit serial programmer, Atmega 328 microcontroller, analog pins, voltage pins, ground pins, and a lot of stuff. Okay, so now I will show you it in real time. Okay, so just wait a second. Okay. Okay, so just wait a second. Okay, sorry. Okay, so let's go through the main components. Okay, so here this one. Okay, okay. So this is the USB plug for Arduino, and this one right here is crystal oscillator. There's a crystal oscillator at which frequency of 16 megahertz. Okay, this one right here. Okay, I think you can see it clearly now. Okay, I will show it even here. This one. Okay, so this is a power jack of voltage 7 to 12, okay, volt, and just above that is voltage regulator, then a crystal oscillator right here, and then a reset button here. Okay, there's a reset button right here, and then okay, reset button here, and then digital ground pins and analog reference pins. There are so many pins right here, and a set of digital input output pins on the top. Okay, so uh, I think showing pins through video is a very difficult thing. Okay, so I will show it in the PDF itself. Okay, I think that is better. Okay, so the pins from one. Okay, let's start from 0 to 1. Okay, so that will be easier. Okay, so the first two pins 0 and 1, RX and TX. Okay, I probably you won't know what is RX and TX. Okay, so I will tell you about after just explaining what we have on an Arduino board. Okay, after that I will explain all the terms and uh, words like RX, TX, I square protocol. Okay, so like that we have so many terms to learn. Okay, so serial input RX and TX. Okay, simply we can think it's something gives output and for input. Okay, so then we have some digital input and output pins from 2 to sorry from 1 to 13, and the opposite side we have some analog pins. Okay, so we can simply assume so this digital for digital pins, digital sensors, and analog for analog value giving sensors. Okay, so like that. Okay, we can take as digital output. If you want analog output, okay, I think analog output. Okay, so never mind. Okay, then we have ground and an analog reference pin. Okay, then we have an Atmega 168 USB controller and then a power LED indicator. Okay, so if Arduino is properly connected, then it we can find it from uh, the lighted LED. Okay, then we have in circuit serial programmer and an Atmega 328 controller, microcontroller. Okay, so this is the main part. Okay, so all the other things are here to support this Atmega 328 microcontroller. Okay, so without that microchip, the other things are nothing. Okay, so then we have a reset pin, a 3.3 and a 5 volt pin, ground pin, voltage pin. Okay, these things we will learn when we go through the next days. Okay. Okay, so Arduino boards are able to read inputs, light sensor. Okay, finger on a button. Okay, so like we can give signals from sensors. Okay, so probably okay. So let's check what is a sensor. Okay, so I will show you a sensor right here. Okay, this is an ultrasonic sensor. Okay, like ultrasonic waves are used by, you may be familiar with bats. Um, okay, like in the Dracula movies or a Batman. Okay, the same bat. Yes, so they use ultrasonic signals to find objects in front of them. So what they do, they will. Okay, sorry. Okay, so they sends ultrasonic signals from their body to okay, to the atmosphere. Okay, to the environment. And what happens when the signal hits something, then it reaches backwards. Okay, so it can find the distance between them, so it avoids with, so it adjusts its moving path without hitting them. Okay, so that's very fast. And for this one also the same principle. One is transmitter and one is a receiver. Okay, so what happens is, yes, from the transmitter the signal transmits. Okay, then, okay, like this. So we can see there's an ultrasonic sensor inbuilt in its head. Okay, so what happens, sorry, and I have placed an obstacle in front of it here. Okay, so the signal from the transmitter waves, okay, the ultrasonic waves from the transmitter hits the Arduino board's backside. Okay, any object, it will, we can we can take the readings. Okay, so it will hit the Arduino board and then waves return, and those returned waves will be captured by the receiver. Okay, and what happens, these both readings will be taken by the Arduino board from the, we can know that the input and output pins. Okay, so we will give the values, okay, to the input and output pins, those values. Okay, and then we surely have a voltage pin and a ground pin. Okay, so totally four wires. Okay, so that's why we have, okay, maybe not able to see. Okay, so those four wires we have taken from the ultrasonic sensor and put it into a joystick terminal. Okay, like this. Okay, so that's why in our robot every sensors are connected with joystick connectors. Okay, so then coming back to Arduino. So as I have already told you, Arduino is run by the main part is the Atmega 328 microcontroller. Okay, so how it works is, um, we use the IDE programming or C++ or any other programming, mostly IDE. Okay, and then we use a compiler, and using the compiler, okay, compiler is a, so okay, compiler converts the program into a hex file. Okay, hex file is something that can be read by the board. Okay, and then using a burner or a programmer we will send the hex file uh, to the all the data to the microcontroller so that it can work. Okay, so then, okay, so coming to the next, so and for this to work, okay, so this is a microcontroller, so we send in data and get data from this. So we need it to store some data. Okay, so we need a bootloader. Okay, bootloader means it creates an environment inside the chip for the data, so that the data can be stored for some time. Okay, so so a bootloader is pre-installed in the Arduino. Okay, so there are 14 main pins as we have told, as we have seen on the PDF. Okay, from 0 to 14. Let's go through it one more time. Okay, okay, we have from the 0 to 14. Okay, so sorry, 0 to 13, total 14 pins. Those total 14 pins are digital pins. Okay, digital input and output pins. Okay, so they take input values or output, or we they give output to the sensors or any products as we use. Okay, and then we have an I square C pins. Okay, so those I square C pins are A4 and A5 here. Okay, I think, F4 and F5, the last two ones in the analog pins. Okay, so what is I square C? It's a protocol. Okay, I will tell you after some time. Okay, and then we have serial protocol, sorry, SPI protocol pins. Okay, those pins are uh, 10 to 13 are actually SPI protocol pins. Okay, from 10 to 13. Okay, and then we have serial protocol pins. Okay, SPI protocols are different, serial protocol is also different. Okay, so the serial protocol pins are RX and TX. Okay, that is the serial out and serial in, both are serial protocol pins. Okay, protocol means it's a set of laws, or yes, set of laws um for this electronics should work. Okay, so then we have, okay, then PWM pins, that is from 3 to 11. Okay, 3 to 11 are PWM pins. Okay, so what is a PWM pin? I will tell you later. Just after 5 minutes. Okay, after completing the pin section, and then what? Then we have LED in pin 13. Okay, if you want to light an LED within the Arduino board, we can use the pin 13. Okay, and then and one more thing. Okay, the RX, about the RX and TX. Okay, if we upload, okay, now we have, just assume we have learned how to program in Arduino, and we have connected the circuit, and we have to upload a code into the Arduino board. Okay, so if you have any wires connected in serial in and serial out, I mean the RX and TX, the code won't work. Okay, because the uploading won't happen, because okay. Okay, so during uploading any code, make sure RX and TX are free. Okay, and then Arduino has a flash memory of 32 KB. Okay, it's non-volatile, and it has a then what? Then okay, then let's check what is I2C protocol. What is then SPI protocol, and what is serial protocol? Okay, so I2C protocol, its full form is integrated circuit. Okay, it's a best interface connection protocol incorporated into devices for serial communication. Okay, so it's a set of protocols for serial communication. Uh, if you want to go deeper into that, it will be get more and more complex. Okay, we don't want that kind of stuff to for mostly programming in Arduino. We want that kind of stuff, but we just need to know what is I square C. Okay, that's enough. Like it's a connection protocol for devices for serial communication. Okay, and it uses a two bidirectional open drain lines for data. Open drain lines for data. Just assume two lines. Um, those lines are here, the A4 and A5. Okay, uh, they're called SDA and SCL. Okay, they are called SDA and SCL. Okay, so how it works is, A4 is also called serial data. Okay, it transfers data, and the next one, the F5, it clocks the signal. Okay, it is also called a serial clock. So as we have said, it's an open drain path. What is an open drain? This if open drain means it is driven by a single transistor which pulls the pin only one voltage. Okay, to one voltage. Okay, so maybe you are confused. Okay, open drain is driven by a single transistor which pulls the pins to only one voltage. Okay, so how it works is just assume two lines, the like two sides of a scale. Okay, and a transistor on top. Okay, and as per the connections we have given, we can pull it to a single line. Okay, since if it is on open drain, then it will only pull to a single line. Okay, then transistor. Okay, transistor is a solid state control device. Okay, um, uh, so to explain a transistor, just assume three terminals. Okay, so first two terminals are connected. Okay, so in between a point. Okay, so and the third terminal. Okay, so just based on the voltage or current receiving in the third terminal. Okay, uh, the device, okay, this control device or the transistor allows or disallows the current flow to other two first two terminals. Okay, so like A, B and C. Okay, A and B, the current flow to A and B is decided by the voltage or current delivered to C. Okay, and then clock. We have said about serial clock. Okay, if you get deep into the Arduino, you will have to learn what is a clocking or serial clock. Okay, clock is it's a state which it constantly pulses logic level high or logic level low with the time duration. Okay, so logic level is simply saying it's a voltage difference between signal and ground. Okay, or we can simply say it's a state which a digital signal can process, and those are the both states. Okay, so how it takes how a sensor or a chip calculates its the time is using this clocking. Okay, and then let's go to SPA protocol. Okay, high square C protocol. There are a lot of stuff to learn inside. Okay, if you go inside an I square C protocol, there's a lot of stuff there. Okay, so that's why I'm not going deeper into that. Okay, just going through the ground, just to make sure there are certain things like that. Okay, so then SPA protocol. Okay, or peripheral interface, serial peripheral interface protocol. Okay, it provides where it provides something called full duplex communication at very high speed. Okay, full duplex means data can be okay full. What is a full duplex is data can be transmitted on signal carrier at same time. Okay, so like a two-way bus. Okay, sorry, a road. Simply saying a two-way road. Okay, cars can go in both directions at the same time. Okay, that is simply saying a full duplex. Okay, half duplex means like a one-way road. Okay, full duplex is in like a normal road. Okay, at high speeds. Okay, and with communication at high speed. So that is serial peripheral interface protocol. Okay, and then let's get back to Arduino. Okay, and RX and TX pins. Okay, so RX and TX pins are the receiving pin and the transmitting pins. Okay, and I have also told you about the term PWM. It's simply pulse width modulation. Okay, pulse width modulation pins are used to get analog results with digital means. Okay, so I think this stuff is getting bored. Okay, so let's go back to robot. Okay, let's get back to no robot. Okay, okay then. So sorry. So this is a robot we have made with this Arduino board. Okay, so let's just check. Uh, let's go through the main specifications and parts and sensors used in this robot. Okay, so you won't be seeing this Arduino board here. Okay, because it is just inside this board. Okay, um, let's pull this out. Okay, okay, you can see Arduino is placed here, and we have used so many JST connectors to connect sensors. Okay, so why we have done this is we don't want to be afraid of getting short circuited or no, or we don't have any connection troubles like we do with a breadboard. Okay, so and still we have all the pins sorry available here. Okay, as the same direction of as uh, at the same position of the digital and output pin, sorry, the digital and analog pins. Okay, you can see here both pins are same, but what the difference is, instead of fixing lines, sorry, instead of fixing wires, okay, the male pins to the female pins, what we have done is we have taken all the wires and connected it with such JST terminals. Okay, okay, then um, so let's go through what we have in this kit. Okay, so you can see it's a head, it's rotatable, so it has a servo. Okay, so we can see the ultrasonic sensor, and then there's a OLED display. Okay, and now you may have noticed this one, sorry, this one, this is an IR sensor. Okay, or we can say line following sensor, and you can see the servo here. Okay, you can see the servo here, and for motors. Okay, and then as we have already said, monitor to display battery voltage, and then Arduino board, and Arduino hat. Okay, Arduino hat, uh, custom made by the company. Okay, so on top of board. Okay, let's check what we have on top. Okay, and then the battery box here. Okay, and there's a sliding door to fix motor connections inside here. Okay, and let's check what we have on this one here. Okay, see we have a buzzer, a potentiometer, an IR receiving device for receiving data from remote control. Okay, and then to light detection sensors on both sides. Okay, the pink one here. Okay, and then pins to connect servo. Okay, so for that so now let's go to the PDF. Okay, so this is the ordinary hat. Like I have said, okay, it's an pin for slot for ultrasonic sensor, and then light detection sensor. Okay, that is LDR2. Okay, and then LDR1. All kind of inputs for motor driver, for potentiometer, for IR receiver, switch, and we have two switches, and then connection JST terminal for OLED display, buzzer, line for sorry, JST terminal for line following sensor, and a power LED. Okay, additional power LED on top of this board. Okay, and then a Bluetooth module, servo, and we have all the analog and digital pins. Okay, as we have on this Arduino board. Okay, and the reset pin is also integrated to the top of this board. Okay, so the main difference between this one and an Arduino is it doesn't have what the Mega 328 processor. Sorry, the microchip. Okay, so Arduino made the programming more easy, and this hat makes the connections more easy. Okay, so uh, I don't want to check all the time where's the ground, where's the voltage, or where do I have to connect this one. Okay, so like that, we don't want to be okay. We don't need to care about getting short circuited or and destroying the circuit. Okay, so then it's about downloading the Arduino IDE software. Okay, so okay, okay, and then programming. Okay, so I think you have not seen anything. Okay, sorry. That was a mistake. There was a mistake. Okay, so this is the Arduino hat. Okay, I'm sorry. I have to repeat it again now. Okay, so this is the Arduino hat, and you can see the battery input for with the ST terminal. Okay, all these ST terminals uh, are for this ultrasonic sensor, line following sensor, uh, a monitor display, OLED display, and line following sensor. Okay, and then okay now okay now I'm gonna show how the kit actually works. Okay, okay you can see here I have removed the head. Okay, so now this is where we connect the servos. Okay, and this is where okay two just connect cables from both ultrasonic and line following sorry the OLED display. Okay, so it is placed inside this acrylic pieces. Okay, so this is we have assembled it here. Okay, we have cut we have used laser cutting to cut these pieces and then assemble here. Okay, so this is just a cable and this is how we are gonna connect. Okay, and then the line following sensor. Okay, so both are connected. So we don't want to solder or we don't get any time wasted. Okay, so then to the main board now. Okay, so just wait a second. I will zoom the video. Okay, it is better not to zoom. Okay, So in this board, the ultrasonic connections. Okay, so this is the terminal for ultrasonic sensor. Okay, so we can see, okay, like this it is not going inside because there is only one way we can put here. Okay, you can see there's two small cuts here. Okay, so you don't want to be afraid of getting short circuited or destroying the sensor in any other way. Okay, so connections are made easy. And then the OLED display. Okay, and it is written all over here. Okay, now let's check where is OLED displays. Just terminal, that is right here. Okay, I think you can see the writings here. Okay, I think it is not much clear. Okay, now it is clear. You can see OLED display. Let's check what are the others. Oh, LED display, then potentiometer, motor driver, USB, and then Bluetooth right here. Okay, buzzer. Okay, let's connect Bluetooth. Sorry, OLED display. Okay, so it is connected. So like this, we can connect all other sensors. Uh, okay, so that's it for today, I think. So let's continue the class tomorrow. Okay, from tomorrow we will start coding. Okay, so okay, so nothing. Okay, so from tomorrow we will start coding. So uh, so totally we have around, we can do around 35 codings, 35 robots. Okay, 35 projects with this robotic kit. Okay, with this Arduino. And after this 35 programmings, okay, there won't be anything else to learn from Arduino. Okay, because we interface motors, ultrasonic sensor, line following sensor, and then what, then servos, uh, buzzer, potentiometer, light detection sensors, and switches. Okay, we interface, and OLED display, sorry, and we interface all these 6 7 8 set of sensors uh, into a single robot. Okay, like autonomous robot. Okay, yes, and then we can make line following robot. We can make remote controlled, smartphone controlled robots. Okay, so we will start from a simple one, and then during these workshops, okay, during the live classes from the next day, we will only go through the main and important, just 12 robots. Okay, so let's wind up today's live session. Okay, okay, see you all tomorrow. Bye.